Hello children, you're welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. I am Okwagbaje. Today in mathematics, we're going to be working on something new. Specifically, we'll be looking at fractions, and I'm sure that you have come across fractions at some point in your learning journey, but perhaps today you will learn something new. But as is our usual practice, we will do the correction to the previous assignment. You were asked to find the LCM of these sets of numbers. I'll just take number one, and then I'm sure that you will have gotten the rest. Number one, just to remind you, to find the LCM of 54 and 72, we express 54 as a product of primes, and we express 72 as a product of primes as well. So doing this, we see that 54 expressed as a product of prime is 2 having a power of 1 and 3 coming 3 times. And 72 is 2 in 3 places, 3 in 2 places, which I'm sure that you still recall. And now to find the LCM, we take the 2 with the highest power, which is 2 in 3 places, and the 3 with the highest power, which is 3 with the power of 3. Now 2 with the power of 3 is 8, and 3 with the power of 3 is 27. 8 times 27 is 216. I'm sure you got that right. Now, just to run through the other ones for you, we do it likewise, and we see that the LCM is 240, 430, and 48, doing the same thing. And then for 22, 66, and 132, running through it, we see that the LCM is 132. I believe that you got the answers right. Give yourself a tick, and I celebrate you with a cheer. Now moving on to that work that we want to do today. Here I have a rectangle. It is a whole rectangle, one whole. You know, I can share this into different parts. I'm going to divide it into 3. Now, each part is called 1/3. 1/3. Now, I'm going to color 2 of the parts, and that means I've colored 2/3. You know, just like I said, 2 apples. 2/3. And we'll write these 2/3 as 2/3, like this, or like this. You're familiar with this from your lower primary work. Now, observe that the yellow rectangle, that's our focus. I'm not going to increase it. I'm just going to make more rooms. Okay, so we have 2 rooms that are shaded and 1 room not shaded. Okay, so now I increase the number of shaded rooms, but I do not increase the size of the rectangle or the yellow rectangle. So now I have 4 rooms shaded out of 6, but the size is still the same, and that means that the first one, 2 out of 3, is the same thing as 4 out of 6. So we'll do likewise. I continue to increase the rooms. Now we have 8 out of 12. So 2 out of 3 is still the same as 8 out of 12 because I have not increased the yellow rectangle. And I will continue likewise, and now it has become 16 rooms shaded out of 24. I can even remove all these lines and have it as 6 rooms shaded out of 9. Okay, so all these fractions are having the same size. Throughout the partitioning, the yellow shaded part did not increase, and that means that the fractions are of the same size. Now these are the fractions again: 2/3, 4/6, 8/12, 16/24, 6/9. They are equal in size, and these fractions exactly are what we call equivalent fractions. Say equivalent fractions. Good. Equivalent fractions in mathematics. So let's check out the learning objectives. By the end of the day, you should be able to form your own equivalent fractions using the method that I will show you. You should be able to compare 2 fractions and determine which one is bigger. You should also be able to compare 3 fractions and arrange them from the biggest to the smallest. Are you ready? Well, to get the best out of this lesson, it is best that you drop your pen and paper and focus on me 100%. Of course, I will give you the time to write. Let's get started. Equivalent fractions, of course, is what we're starting with. What are they? Equivalent fractions are fractions that are of the same size as I have shown you in the previous slides. I'll take that again. Equivalent fractions are fractions that are of the same size. Now, to form equivalent fractions, all we have to do is to multiply the numerator of a fraction and the denominator by the same number, or we divide the numerator and the denominator by the same number. Let's check out some of the fractions that we've seen before. We have been able to establish before in the previous slides that 2/3, 4/6, 8/12, 16/24, 6/9 are equivalent fractions because the yellow rectangle that we use to represent them are of the same size. Now, I'll bring the rectangles again. This is 2 over 3, of course. But now that is 4 over 6, the same yellow portion. But you see that here, the numerator is 2, I've multiplied with 2. The denominator is 3, I've multiplied with 2 again, times 2 times 2. And then I get 2 times 2 is 4, 3 times 2 is 6. And that is why here, 4 rooms are shaded out of 6. Okay, but the fractions are still the same, as long as you multiply with the same number. Let's check out the next one. Here, I'm multiplying by 3 now. That means that I've increased this one room here. I've increased it into 3, and this other one room into 3 rooms. So I've multiplied by 3. And then the unshaded one, I've increased it into 3 rooms. Okay, so that means I'm multiplying by 3. So now 2 times 3 is 6, 3 times 3 is 9. That means that altogether I will have 6 rooms out of 9 rooms shaded. The same thing applies to the other ones. 2 times 4 is 8. Then 3 will also be multiplied by 4. And I will get 8 over 12, which is represented like that. And as you can see, the yellow part is still of the same size with this one altogether. This yellow part here and this yellow part here, still of the same size. Okay, so moving on, 2 times 8 will give me 16. 3 times 8 likewise will give 24. So you can continue to do that. All these fractions will be the same in size. It's just that it is the numbers of the numerator and the denominator that will be changing. So if 2 over 3 is the same thing as 16 over 24, they are the same size. But 2 over 3 is what we call the lowest terms. Now, do you remember lowest terms from our work on highest common factor? Yeah, because between 2 and 3, nothing can divide. If I divide this by 2, 2 goes here 2, 2 goes here 3. I will come back to this. If I divide this by 4, 4 goes here 2, 4 goes here 3. I will come back to 2 over 3. So all these other ones are just the same thing as this, except that we have scaled them up a little bit, but they are of the same size. Now, in the same way, we can form equivalent fractions for other fractions. Okay, it's not only 2 over 3. Look at this fraction, for example. This is 3 over 5. But this is another fraction that is the same size as 3 over 5. And what did we do? We simply multiplied top and bottom by 5. Top by 5, 3 times 5 is 15. Then 5 times 5 is 25. And this is where you can make a mistake, my friends. Some pupils will multiply the top with one number and the bottom with another number. You will not get equivalent fractions that way. The fractions will no longer be of the same size. You will not be able to reduce it back to this. But from here, if I divide by 5, 15 divided by 5, I will get my 3. And if I divide 25 by 5, I will get my 5. So I will always get back to the starting point. Let's check out another one. Now, this one shows that it's not only multiplication that we can use to form equivalent fractions. Here, I'm dividing 42 by 6. And I have to divide the number below by 6 as well. So 42 divided by 6 will give me 7. 48 divided by 6 will give me 8. Equivalent fractions. So the principle is the same. If you want to form equivalent fractions, multiply the top with the same number as you multiply the bottom. Or divide the top with the same number that you will divide the bottom with. Now, you should be ready for some work of your own. So let's check out this one. What number do you think will be in this box? Something is missing. I've multiplied, I've increased this one. That means I've multiplied it with something to get 64. So I have to multiply 5 with the same thing. So what is that number? It's for you to do. You have 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That number, my friend, is 40. And why? Because I would have scaled up 8 by 8 to get 64. 8 times 8 gives me 64. Then I will multiply 5 by 8. Did you get it right? Here's your chance if you did not. Take another one. 4 over 9 will give me 28 over something. What is that number? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's check it out. That number, my friend, is going to be 63. Why? Because 4 times 7 is 28. So I will have to multiply 9 by 7 too. That will give me 63. Do you want to try a final one? Check it out. 54 over 60 will give me something over 10. Mind you, 60 to 10, that means I have not multiplied, I have divided. So what do I divide 60 with to give me 10? 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Let's check it out. That, my friend, will be 6. 60 divided by 6 will give me 10. So 54 will also be divided by 6. Okay, and I will get 9. I'm sure that we'll have that in order. Now, let us consider this question. Which of these two fractions that you see here, 3 over 8, 11 over 32, they are not equivalent, and that means they are not equal. In fact, one is bigger than the other one. Now, if you were to decide, which one would you say is the bigger fraction? Think critically. Which one would you say is the bigger fraction? Is it 3 over 8? Is it 11 all over 32? Well, the truth is, even Unkwagbaje does not know. So let's see if we can find a way of determining the bigger fraction. Okay, so I take that whole rectangle again, and I divide it into 8 portions for the 3 over 8, and then another whole rectangle. You can see that they're of the same size. I divide it into 32 portions for the 11 over 32. So of course I'm going to color 3 parts out of 8, and then I'm going to color 11 parts out of 32, and then we can compare the length of the colored path, and we'll see which one is bigger. Okay, so let's see, the 3 parts out of 8 stops here. Okay, so now it looks as if 3 parts out of 8 is bigger than 11 parts out of 32. And that means that in a test, if somebody scores 3 over 8, another person scores 11 out of 32, the person that scores 3 over 8 has done better, really. But on the surface of it, we might not be able to know. Unless, of course, if we have a way of converting 3 over 8 to something all over 32. And so what we can do is that this same 3 over 8, we can divide it into 32 parts. This same fraction, we can divide it into 32, like this. See, I've now divided it into 32. So how many parts out of 32 are shaded? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 parts out of 32. And this is 11 parts out of 32. So if we have a way of making the bottom to be the same, 32, 32, I mean, somebody that scored 12 out of 32 has done better than somebody that scored 11 out of 32, okay? So that 3 over 8 is equivalent. It is the same thing as 12 out of 32. Look at 3 times 4, 12. 8 times 4, 32. So now it's easy for me to compare them now. If I'm able to change one of them to the denominator of the other, so 3 over 8 is bigger than 11 over 32. Let's see another one. So I'm just going to use rectangles again to represent this fraction. So the first rectangle will be divided into 8 portions, and the second will be divided into 12 portions. And of course I'm going to color them. So let's color code them now. See, 8 parts should stop right here, and 5 parts out of 8. So obviously it's looking as if 8 parts out of 12 is longer than 5 parts out of 8. So this should be the bigger fraction. But of course, if we don't draw the diagram, we will just make sure that they have the same denominator. And there's no way I can make 8 to become 12. So what I do is that I'm going to make everything to have a denominator of 24. Divide it into 24 portions. And now this automatically becomes 15 parts out of 24, because if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 15 out of 24 portions. But this one here will become 16 parts out of 24 portions, because obviously if I multiply 8 by 2, I'll get 16. 12 by 2, I'll get 24. So now it's easy for me to compare 15 out of 24, 16 out of 24. Which one is bigger? Of course, 16 out of 24 is bigger. And this just gives us a way of comparing fractions. If they don't have the same denominator, use our previous knowledge on equivalent fractions to make sure they have the same denominator. It will be very easy for you to compare them then. So let's look at some real problems. To compare fractions like this, we form equivalent fractions. We use the LCM of the denominators. We use the LCM of the denominators to form the same denominator. Okay, then we compare. So let's see. Here is an example. We want to compare these two fractions, 5 over 6, 7 over 9. We do not have to waste time drawing rectangles and shading. I mean, that's a lot of work. What we can do is that we can make sure that 5 over 6 and 7 over 9 have the same denominator. Okay, and like I have said earlier, the denominator we usually use is their LCM. I won't waste your time telling you to find the LCM for today. I will tell you all the LCMs. For instance, the LCM of 6 and 9 is 18. So I have to make this fraction have a denominator of 18. I'll make that fraction have a denominator of 18. So let's go. So 5 over 6, to make it have a denominator of 18, I will have to multiply by 3 because 6 times 3 is 18. The bottom first. 6 times 3 is 18. That means I have to multiply 5 by 3, and that will give me 15. Now, what do I multiply by 9 to get 18? Of course, that's 2. So 9 times 2, 18. Then I will multiply 7 by 2. 7 times 2 is 14. So this one is 14 out of 18. And this one is 15 out of 18. So obviously, which one is bigger? It is this guy. So I gave it the 2 ends, and I give this one the 1 end. This is greater than that one. Let's check out another one. We are to arrange these fractions. We've been given the LCM, which we are going to use as the common denominator. The LCM of 3, 5, and 6 is 30. So we have to make sure they have a denominator of 30. So let's go. So it will be easy for us to compare them. Start with this one. What do I multiply by 3 to get 30? Of course, that's 10. So 3 times 10 is 30. So that means I'll multiply the one on top with 10 as well. 2 times 10 is 20. Now, let's go with this one. We want to make it 30. What do I multiply by 6 to give me 30? Of course, that's 5. So 6 times 5 is 30. And I will have to multiply 2 by 5 as well. 2 times 5 is 10. Then let's go to the last one. What do I multiply by 5? I will multiply 5 by 6 to give me 30. So I will multiply the one on top by 6 as well. 3 times 6 gives me 18. Now it's easy to compare. 18 out of 30, 10 out of 30, 20 out of 30. Which one we are to arrange the fractions? Which one is the largest? 20 out of 30 is the largest, of course, followed by 18 out of 30, followed by 10 out of 30. So 20 out of 30 is the same thing as 2 over 3. 10 out of 30 is the same thing as 2 over 6. So bring this one first. This is number 2, and this is number 3. So we rearrange, and you can see that 2 over 3 is bigger than 3 out of 5, and then that one is also bigger than. You don't have to put these signs, but you can rearrange. Now, I'm sure you want to do some of your own. You are eager to test and say. All you have to do, my friend, is find the LCM of the denominator, and that will tell you what to use as the common denominator. So I'm going to give you some to work with as your homework, and which, if you do them, you get a chance of winning packs of Good Life Magic Juice. You have to arrange these fractions, rather, in order of size from the smallest to the biggest. You have 10 seconds to copy. 9, 8, 7, 6, 5, 4, 3, 2, and 1. I will now hand you over to Uncle Popo for a general studies lesson that promises to be interesting. Till I come your way in the next class, remain wonderful mathemagicians.